Okay, so when we do the sigma notation, remember there's 3 questions you have to be able to answer. How many terms are there? What's the first term? And what's the common ratio? Now the nice thing with infinity is there's going to be an infinite number of terms. You don't need to answer that question. But we still need to figure out, for example, what's the first term? So in this one, it'll be 1 over 3 to the 1, which is 1/3. And can anyone pick out what the common ratio is going to be? I'll give you some choices. It's either 1, 3, or 1/3. Yeah, Danny? 1/3. If you're not sure, try a couple terms. 1/3, 1/9, 1/27. So the common ratio here is 1/3. Okay. So everything fits. The infinite sum is going to be 1/3 divided by 1 minus 1/3. So that'll be 1/3 divided by 2/3. And I think that's a half. Okay, so try the next 2. See if you can work it out with sigma notation. Okay. So I think the next one's 4. Okay, so I'll take a look at the next one here. First term is going to be 2 times 1.1 to the 0. So that's 2. Common ratio is 1.1. Okay, so the answer for the last one's negative 20, right? What? Well, why not? I put it in the formula. The ratio is too big. So the common ratio here is 1.1. It's out of range. It's just going to keep growing. This is 10% extra every time the term is grown. So there's no finite sum here. Okay. So you should almost feel a little bit insulted by the next couple questions because the formula is so easy to rework. But I'm going to have you do them anyways just because I'm mean like that. But here are your clues. The sum of the infinite series is 63. The first term is 21. What's the common ratio? The sum of an infinite series is 24 over 7. The common ratio is negative 3 over 4. What's the first term? Okay, so I'll let you work on those clues. We'll recap. Okay, so I'll try to catch up to you. You can check your work up against mine. I have been known to make the odd mistake, so you may want to double check that it wasn't me. Okay, so I'm pretty sure those are correct. If you want to double check over against your answers, I got a common ratio of 2/3 and a first term of 6. Okay. Okay. So I'll show you one weird thing that's kind of, I don't know, it's a little different that you can do with infinite sum. So the number 0.9 repeating, okay, so you've seen those repeating numbers in your calculator, 0.9 repeating, we can actually express this as an infinite sum, and it's kind of strange, our results. So that's what I wanted to show you. So I'll give you a hint here. What I want you to do is write this as 0.9 plus 0.09 plus 0.09 plus, and keep going. Okay, so you tell me, if you do this infinite series, what do you get? Okay, so your first term is 0.9, and what's the common ratio? What's the common ratio in this series here? 0.1 is correct, yeah, so it's 0.1, so that'll be 0.9 over 0.9, which is 1. So does your intuition, do you believe that 0.9 repeating forever is the same as 1? For most people, they're kind of like, no way, that's not the same thing. So, but you have to be careful because this symbol here looks different than this symbol here. So it's natural for us to go, they're not the same thing. But this quantity over here actually describes the same as this quantity over here, which is weird, I know. So if you want to learn more, then go home and Google, does 0.9 repeating equal 1? But there, that's kind of strange. I still find it very strange that you can actually do this. And anyways, there you go. So here's another one. First term of a geometric series is 81. Third term is 1. Find the sum to infinity. And there's going to be two possible series here. Okay? So first of all, what do we need to find in order to actually solve this? We need some information to get an infinite series. Common ratio is what we're missing. We have the first term. It says the first term is 81. We don't know the common ratio. So see if you can figure out a way to find the common ratio. And if you can do that, you should be able to find two infinite series. And I'll give you a little hint. Think about your sequences. We did stuff like this in sequences that might help you. Okay, so the hint I was referring to was this one. Whoops. So r squared is 1 over 81. So r is 1 over 9. But because it was squared, there are two possibilities. Right? Since it was squared, it could be positive or negative, which means I could have two possible sums. It could be 81 over 1 minus a ninth, or it could be 81 over 1 minus negative a ninth. So that would be 91.125, and in the other, $72.9. So it shouldn't surprise you that the sum that has a negative common ratio has a smaller value, because some of them are subtracted, right? So it's going to be smaller than the one that has all positives. So the last two questions are to get you to kind of think a little bit. They're not any more difficult than anything we've done. It's just that they have lots of letters in them. Okay. So let's try and figure out what it is that we're looking for in the first one. It says determine the values of x such that the following infinite series has a finite sum. So that's a lot of language in there. What comes to mind when you hear the words infinite geometric series and having a finite sum? What do we know about that? Connor?
X has to be between -1.
You're absolutely correct, but let's call it the common ratio. Okay, there's an x in here which may or may not be the same as the common ratio. So let's just say that the common ratio has to be between -1 and 1. Okay? So that means a natural thing for us to do is find the common ratio. Can anybody tell me what the common ratio would be in this series? Sure, Danny? Yeah, so it's a quarter x, the common ratio. If you take any term and you divide it by the previous, you're going to get 1/4 x divided by 1. Or if you did it this way, you'd still end up with 1/4 x, any term divided by its previous. So if I know the common ratio is a quarter x, this is what I know. Okay. And we'd like it just to have an x in there, so what could I do to get rid of that quarter? Sorry? Yeah, multiply everyone by 4, and now I'm at my solution. So as long as x is in between -4 and 4, this series converges. So along a similar lines, don't let it scare you that there's lots of letters and things in here. See if you can give me a formula for this infinite series, okay? And tell me, what would it be? I know there's a's in there. Your answer is going to have a's in them too. See if you can work it out. Okay, so that's good. I see a lot of people have figured out this. The first term is the first term. I also see a lot of people who figured this out, which is excellent. Common ratio is any term divided by the previous, so how about those? They're easy. Okay, that means the infinite sum is going to be the first term over 1 minus the common ratio. So now all that's left to do is a little bit of fraction work. So that's a divided by a plus 1 over a. So a plus 1 over a. Now, does anybody know a good strategy to get rid of complicated fractions like that? Okay. We'll talk more about the strategy in trig, but you could think of this as having a 1. So there's two fractions, one on top, one on the bottom. If you look at the denominator, 1, and you look at a, and we say, what's the lowest common denominator between those? Between 1 and a, it's going to be a. So if I multiply top and bottom by a, I haven't changed the fraction. That's like multiplying by 1. And what that means is this a is going to cancel out with that one, and I'm going to end up with a squared over a plus 1. So we'll practice that kind of complex fraction stuff more, but that's one way you can get rid of the complex fraction, and that would have been the answer, a squared over a plus 1. So one last question I'm going to leave you with, because it was on a previous provincial. I put one in there that was, it's in the extra questions from homework, but if you really know your stuff, then this is the kind of question that you should be able to answer. So here's what it looked like. It's a good question, that's for sure. So it gives you a square, and it tells you that each one of these points here is a midpoint. So that's how you make the next square, is you join the lines between the midpoints like this. Okay? So the first question that they asked was, what is the area of all the squares? And this is an infinite amount. The second question that they asked was, what is the perimeter of all squares? So let me just tell you my own experience. I would call this like a 100% question. Meaning, if you're the kind of person that's like, I want to get 100% on this provincial, and that's the level of standard you're holding yourself to, that's awesome. This is the kind of question that shouldn't scare you. You should be able to do this. If you're still like, no, 98's okay with me, then this question is probably, you're going to find it a challenge. But when we saw it, the math department looked at it and saw it on the provincial exam, a lot of us went, wow, this is the question that's trying to separate 100% students from 98% students, because, you know, you look at it and it's like, wow, is it even possible to do this? But it's not a bad question. If you work it out and you take your time, you'll find it's not so bad. So ask me about this. If you try it, you'll probably finish your homework pretty early today. There's only a few questions. Try it and see if you're smart enough to do the 100% question. I'm sure that most of you are, so I wouldn't stress out about it.